Okay, now that we have learned about motion, speed, and a change in motion, we're going to start talking about how forces can help start something to move, stop it from moving, and so we're going to look at how motion is created. This goes with learning target 15, compare and contrast between balanced and unbalanced forces and be able to create a force diagram for each. Okay, so a force is a push or a pull that is applied to matter. There are a lot of different types of forces. Okay, the first type of force is contact force, or we call that a normal force. Anytime matter is in contact with other matter, there is a contact force between. So, example is these two football players are making contact. That's a normal force. Another force is friction. Friction is a force that goes against motion. So, you see this guy right here is trying to pull this box to the right. The force of friction goes against the motion and it goes to the left. Friction exists between two objects that are making contact. Next type of force is gravity. Gravity is a force that acts on any type of matter, anything that has mass. And remember, gravity increases with greater mass, but it decreases the farther away. So distance will decrease gravity. Another type of force is tension. Rope has force of tension. So if you look at this picture, these weights that are pulling on the rope, that the weight has a force of, these little masses have a force of weight, and going against that mass, or that force, I'm sorry, is tension. Okay, another force that we've talked about is air resistance. So remember, air resistance has to do with surface area. The greater the surface area, the more air resistance an object has. And air resistance always goes against the force of gravity. Okay, and the last force that we're going to talk about is weight. Remember, mass stays the same, but objects can have different weights because weight depends on mass and gravity. So remember when we go out into space, if something like our moon has a smaller mass, it has less gravity, so you would weigh less on the moon compared to Earth. So if you look here, the acceleration on Earth is 9.8 meters per second squared. On the moon, it's 1.6 meters per second squared. So if you take the mass, 2.5, multiply it by 1.6, you get a weight of 4 newtons. 2.5 times 9.8, you get a weight of 25 newtons on Earth. Okay, when we look at forces, we always want to look at all the forces that act on an object. So a net force is a combination of all forces. Forces in the same direction add together. Forces in opposite directions we have to subtract. So if you look at this example, we've got 20 newtons of force being applied to the book to the right. Then we have 20 newtons being applied to the book to the left. So because these two forces are in opposite directions, okay, then we have to subtract. So because they are in opposite directions, we're going to subtract these two forces. So it's 20 newtons minus 20 newtons, 0 newtons. That means if there is a 0 net force, this book is stationary. It's not moving. Okay, one of the ways that we can tell if forces are causing motion is whether we have balanced or unbalanced forces. Balanced forces are in opposite directions, but they're equal. So for example, this example up here, we had two forces that were in opposite directions. They were equal, so the net force was 0, so that is called a balanced force, and they're not moving. Kind of like in a tug of war. So you guys know when we have our homecoming assembly, and once you get to high school, you get to have tug of war contests among the different classes. So tug of war is a great example. If both sides are pulling with the same amount of force, then the rope will not move. And I can't draw very well today. But let's assume these arrows are both the same amount of force. If you guys both pull in opposite directions, the same amount of force, the little flag here will not move and we will not win. An unbalanced force is actually when forces move in opposite directions, they're not equal, or sometimes forces can move in the same direction. This is going to create movement. So in the example of the tug of war, this side is pulling with more force than this side. So because this side has more force, it's an unbalanced force, they're going to move, and this side wins the tug of war. Now, one of the ways that we can tell whether objects are moving or not is to do what's called a force diagram. A force diagram basically identifies any force that's acting on the object. So if we take a look at this block, this purple block that's sitting on the table, well, the force of gravity is always pulling this block down. So that's what you see here. This right here is in green. We would label that G and say that's the force of gravity. That's a very bad G. Okay, so gravity will always be a force that pulls down on an object. So we would label that force gravity. Now, because the table and the purple block are making contact, then the force that goes against gravity is a contact force. Now, because these two forces, if you look at the arrows, they're equal. If they're equal, then that means it's a balanced force because they're equal in opposite directions. This is why the purple block does not move. So when you do a force diagram, you would draw the object that the forces are applied on, draw the arrows that represent the direction of the force being applied. If the forces are equal, draw the arrows equal, and then you need to label the forces. So this force right here is a contact force. The pulling is gravitational force. Some other examples, okay? If we look at this, another block, okay? We've got a block that has a force of normal and the force of gravity. Notice these two are equal. So the block is not moving up or down. But then let's look at these two arrows. We've got this APP stands for an applied force. That usually means contact. So there was some contact force that pushed the block to the right. Notice this arrow right here is bigger than the force of friction. So force of friction, remember, goes against motion. So if anything has an applied force to it, the force of friction will go in the opposite direction. Because the force of friction is smaller than the applied force, we know that the block is moving to the right. Okay, another example of a force diagram. This guy's sitting in his chair. He is making contact with the chair, so there is a normal force. Force of gravity is pulling down on him, but because the two forces are equal, he is not moving. These are a balanced force. This is an unbalanced force. Okay, and you will get a lot of practice with drawing force diagrams. But hopefully, after today, okay, you should be able to tell the difference between balanced and unbalanced forces, and you should be able to draw the force diagrams.